Good morning, everyone. Hello. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium. In this session, we are going to learn about the relation between equilibrium constant and Gibbs energy, standard Gibbs energy. Let's start the session. Okay. So let us see. Here we are using a word called as reaction quotient. We have already studied that what is meant by reaction quotient. Okay, so reaction quotient is represented by Q. What is that? Reaction quotient. Reaction quotient is represented by Q. Right? So for a reaction, for a reversible reaction, A gives rise to B. Q, what will you write? Q, you will write it as concentration of B by concentration of A. Okay, concentration of B, that means product of the concentration of the products by product of the concentration of the reactants. So when is this reaction quotient written for a reversible reaction? Let us also write equilibrium constant for the same reaction. For the same reaction, if I write equilibrium constant, what is that? Equilibrium constant. Let me write Kc for the same reaction. If I write Kc for the same reaction, what will I write? Concentration of B by concentration of A. So what is the difference between Q and Kc now? Both are representing the same. Okay, so these are concentrations of B and A at equilibrium. Okay, these are concentrations of product and concentration of reactant at what position of this reversible reaction? At equilibrium position or at equilibrium state. But whereas Q, when you are writing Q, when is Q written for a reversible reaction? Q is written for a reaction which is not in equilibrium. So here, these are the concentrations of product and reactant not in equilibrium. So B and A are concentrations, equilibrium concentrations of product and reactant. Here when you are writing Q, this B and A are not the equilibrium concentrations. Not the equilibrium concentrations. That's the difference between Q and K. Understood? Though you represent it in similar way, but there is a difference. K is written when the reversible reaction has attained equilibrium. Understood? Now, when Q is equal to K, Kc or Kp, whatever it is, whether it is Kc or Kp, when both are same, then we say that that is the condition for equilibrium. When does Q become equal to K? That is important. When does Q become equal to K? When the reaction is at equilibrium, then Q becomes equal to K. So you have to remember this condition that at equilibrium, Q becomes equal to K. Reaction quotient is equal to equilibrium constant. Okay. So from the thermodynamics, see, mathematical expression for thermodynamic view of equilibrium is, what is that? Delta G is equal to delta G naught plus RT log Q. Okay. Here I am writing log x. Here ln x. I represent ln x, for example. Ln x means log x base e. Okay, if I want to convert log base e, I need to multiply with 2.303 log x base 10. So this minimum information is to be remembered, to be known to you. So here ln q means natural log q base e, right? Now what is delta G here? Delta G is Gibbs energy change. What is that called as? Gibbs energy change. So delta G naught, already you know, standard Gibbs energy change. Gibbs energy change. Okay, standard. When you write not, automatically it will be standard. Standard Gibbs energy change. Okay. Whereas R you know, universal gas constant. And T, what is T? Absolute temperature. Absolute temperature. So these are the terms of in this equation. What is that equation? Delta G is equal to delta G naught. What does it represent? It represents the relation between Gibbs energy and reaction quotient. Describes the relation between Gibbs energy and reaction quotient. Okay. So next, let us see. Now only we have seen one of the condition for equilibrium. What is that? At equilibrium, Q will become equal to K, whether it is Kc or Kp. So from the equation, we have already studied, we know that at equilibrium, what is that? At equilibrium, delta G, Gibbs energy change is equal to 0. Gibbs energy change is equal to 0 at equilibrium, right? And at equilibrium, already we have studied that Q is equal to whether it is Kc or Kp. So I can write K equilibrium. This K equilibrium can be written as Kc or Kp. Depending upon the nature of the reactants, depending upon the reaction conditions, we can take either Kc or Kp. Okay. So substitute that in this formula, delta G is equal to delta G naught plus RT ln Q. So at equilibrium, already what we are seeing, delta G is equal to 0. 0 is equal to delta G naught plus RT K equilibrium. Because at equilibrium, delta G is equal to 0. At equilibrium, Q becomes what? K. Q becomes K. So log K equilibrium. Right? Q becomes K equilibrium. Then what I can write? Delta G naught is equal to minus RT log K equilibrium, whether it is Kc or Kp. Understood? So if you convert this natural log into log base 10, then I can write it as delta G naught is equal to 2.303 minus 2.303 RT log K equilibrium base 10. Now it is base 10. Up to now it is base E. Now we have converted from base E to base 10. Okay. So the same equation can also be written as in a different way. In a different way. I can write this equation as in a different way. What is that? K is equal to e power minus delta G naught by RT. Right? Can I write this? Can I write this? Whether we can write or not, let us see. For this equation, multiply both sides with log, natural log. Log k is equal to log e power minus delta g naught by rt. Okay. So log k is equal to, k means here k equilibrium. Understanding? I am not writing in all the steps. K means here equilibrium constant. So we know that, what do we know? Log e power x is equal to x log e. Anyway, base e. And we know that, and this will be equal to what? X. Right? Log e power x is equal to x. Log e power e is equal to 1, right? Then what you are getting? X. So here log e power x we are having, right? X log e. Then that what I can write? Minus delta g naught by rt log e power e. Log e power e is equal to 1. So I can write it as log k is equal to minus delta g naught by rt. Okay. So from this I can write minus delta g naught is equal to rt log k. So delta g naught is equal to minus rt log k equilibrium. See here, we got the same. We got the same one. So the same equation can be written in this way also, right? This is another way of representing this equation. So what equation we need to remember? What equation we need to remember? So delta G naught is equal to minus RT log K equilibrium. This is base E. If you are converting it into base 10, then delta G naught is equal to minus 2.303 RT log equilibrium constant base 10. Understood? Okay. Next, let us see. Here, if delta G naught is less than 0, if delta G naught is less than 0, so less than 0 means, what does that mean? Delta G naught is less than 0 means that delta G naught is negative. Delta G naught is what? Negative, right? Now only we have seen that, see, then minus delta G naught by RT will be positive. Then we know the formula. We know the formula. What do we know? Delta G naught is equal to minus RT log K. Okay. So now he is mentioning that delta G naught is negative. I can mention that the same reaction. I can mention that delta G naught by RT is equal to log K. So if delta G naught is negative, so negative into negative by RT is equal to log K. Negative becomes positive. That means log K will be positive. If log K is positive, then what will be K? K will be greater than 1. K will be greater than 1. K is greater than 1 means K is positive. K is greater than 1, right? So K will be greater than 1. If K is greater than 1, what does that mean? That means that, which implies that the spontaneous reaction or the reaction which proceeds in forward direction such that extent of the products are present predominantly. So for the reaction, for example, let us take A gives rise to B. K, what you write? K is equal to B by A. So if K is greater than 1 means concentration of B is greater than A. That means product concentration is greater than reactant concentration. So product concentration greater than reactant concentration means products are present predominantly. He is saying that that means product concentration more than reactant. That means more reaction has occurred. More forward reaction has occurred. Has taken place or has happened. Right? So condition you need to remember is if delta G naught is less than 0, then K will be greater than 1. This condition we have to remember. This is important. Okay, understood? This is important. And here it is mentioned that is positive and e power delta G naught by RT is greater than 1. That let us see. Already we have seen that before K is equal to e power minus delta G naught by RT. If delta G naught is equal to negative, then what you get? K is equal to e power minus of minus by RT. K is equal to e power plus by RT. So e power plus by RT gives you plus value. If it is plus value, automatically K becomes greater than 1. Then we can say that K is greater than 1. Understood? Okay. So that is the meaning. So this condition, what we have mentioned is, this condition is important. What condition? If delta G naught is less than 0, negative, then K will be greater than 1. Okay. So we have let us see the another condition. If delta G naught is greater than 0, delta G naught is greater than 0. So we have derived the formula. What is that? Delta G naught is equal to minus RT log K. Or simply we can say delta G naught is equal to minus 2.303, right? RT log K base 10. Condition is if delta G naught greater than 0. If delta G naught is greater than 0, that means positive. So the same reaction I can write minus delta G naught is equal to 2.303 RT log K. So greater than 0. So minus of plus, greater than 0 is plus, right? By 2.303 RT will be equal to log K. What you are getting log K? Log K we are getting it as minus. If log K is minus, what will be K? K will be less than 1. K will be less than 1. If log K is negative, K will be less than 1. Right? So condition, what condition is important? If delta G naught is greater than 0, that means positive, then K will be less than 1. K will be less than 1. So in the reaction A gives rise to B, What do you write K? K is concentration of product by concentration of reactant. Then if K is less than 1, then what does that mean? B is less, A is more. Concentration of A is more than B. That means reactant concentration is greater than product concentration for forward reaction. Okay, forward reaction. So delta G greater than 0. We say that positive means non-spontaneous actually. We have studied that delta G. About delta G we have studied. Okay, here we are speaking about delta G naught. Delta G naught. Right? So this condition is important. What is that? If delta G naught is greater than 0, then K will be less than 1. Understood? Understood? Right. So one more doubt we will be getting. What is that? Is delta G is equal to 0, then we say that it is equilibrium. At equilibrium, will the delta G naught is equal to 0 or will the delta G naught not equal to 0? What about this? Okay, delta G is equal to 0, then we say that it is the reversible reaction is at equilibrium. But if it is equilibrium, whether delta G naught, what about the delta G naught? Now only we have seen the formula that delta G naught is equal to minus RT, okay, or otherwise you can substitute with minus 2.303 RT log K base 10. Okay, when delta G naught will be equal to 0, if K is equal to 1, then log 1 base 10 is equal to 0. Then we can say that delta G naught is equal to minus 2.303 RT log 1. Log 1 is equal to 0. Then you will get 0. When will be delta G naught is equal to 0? When K is equal to 1, then delta G naught will be equal to 0. So for equilibrium condition, we have to remember that only delta G is equal to 0. What about delta G naught? Delta G naught may be equal to 0 and delta G naught may not be equal to 0. That depends upon the value of K. Are you finding? Are you understanding? That depends upon what? The value of K. If K is equal to 1, then log 1 is equal to 0. Then automatically delta G naught will be equal to 0. Understood? Right? So that's the condition. And already we have studied that if about delta G, only delta G is equal to negative, then the reaction is spontaneous. If delta G is positive, it is non-spontaneous. But here all we are speaking about delta G naught, not delta G. We are speaking about delta G naught. So two conditions we have to remember. What are those two conditions? If delta G naught is greater than 0, then what is that? K becomes less than 1. If delta G naught is greater than equal to 0, then K will be less than 1. The other condition we have discussed. What is the other condition? If delta G naught is less than 0, then K will be greater than 1. These two conditions we need to remember. Okay. Right. Let us move to the next part. In this, what is given? A question is given. We are asked to solve it. Okay. For this reaction, gaseous reaction, already Kp is given. Kp is given. The value of delta G naught of the reaction at 627 Kelvin. So what is given? Kp given. Kp is equal to 0.05 atmosphere and the temperature is equal to 627 plus 273, that is equal to 900 Kelvin. So what is asked? Delta G naught is asked, and we know that delta G naught is equal to minus 2.303 RT log K base 10. Here already given Kp, so Kp base 10, that is equal to, then what you get, minus 2.303, right? R value, right, here it is given in atmospheres. Let us take in atmosphere 0.08 okay, 21 liter into atmosphere per mole per Kelvin into temperature 900 Kelvin into log Kp. Kp given as 0.05, right? So let us solve this. Log 0.05 is equal to, separately we are doing it, so log 5 into 10 power minus 2. Okay, so log A into B is equal to log A plus log B, right? Log A, log 5 plus log 10 power minus 2, that is equal to log 5 plus log 10 power x is equal to x log 10. This is base 10, right? So log 5 plus minus into log 10 base 10 is equal to 1. So minus 2 plus log 5. We know that log 5 is equal to minus 2 plus 0.7, that is equal to minus 1.3. So this total log 0.05, how much did we get? 1.3. So then let us multiply that. Kelvin get cancelled, minus 2.303 into 0.0821 into 900 into how much? Minus 1.3, right? Then what do we get? Minus into minus gives you plus. So this is what you are getting, liter into atmosphere, and we know that 1 liter into atmosphere is equal to 1 liter into atmosphere is equal to how much? We have studied from thermodynamics that 1 liter into atmosphere, 1 liter into atmosphere is equal to 101.3 joules. Okay, so then what do you get? 2.303 into 0.0821 into 900 into minus 1.3 minus, no, plus, because minus into minus became plus, into 101.3 joules. Then on calculating this, what you get is answer 22,400 joules per mole. Okay, so then what do you get? You are asked in kilojoule per mole, then 22.4 kilojoule per mole. Understood? Okay, so this is about the relation between delta G naught and K. In very detail, we have discussed each and every point. Hope so you understood very well. Right, thanks for watching. We shall meet in the next video, next class, with a new topic. Thank you.